Hi, my name is Jacob Golden, and my teammates are Jacob Lovern and Cole Westfall. This presentation will cover our journey in making a web application for monitoring security incidents known as the SecOps Security Dashboard for Asante Health. As I said before, Asante was our client for this project. Asante is the largest medical provider in Southern Oregon, and as such, information security is of critical priority for them as an organization. For the duration of this project, our team has worked alongside Asante's Information Technology Security Team, also known as the ITS team. Our two primary points of contact at Asante were Alfonso Powers, CISO of Asante, and Bradley Shubin, who is the ITS team lead. Both of these men helped us to great effect throughout the project. Their advisement brought us up to speed on the project quickly and helped us to plan and develop our code base over the last 6 months. So what motivated the project? Before this web app went into development, security analysts at Asante had to view security incident and training metrics on many different websites. This cost the ITS team time and money, and for a task that Asante knew could be streamlined. The ITS team knew their team and Asante as a whole would benefit from having all of this security data consolidated to a single web location for monitoring. And that's where we come in. Over the next few slides, we'll cover the project's requirements and features. I'll start by talking about the 4 primary features of the project, and then Cole will cover the requirements. Here are the 4 primary features we worked to implement in the last 6 months. First, and most importantly, view security metrics pulled from multiple third-party APIs. This is the core mission of the SecOps dashboard. This is what pulls all the security metrics from multiple websites into our application so that users can see every metric they need on one page. Second, we needed to generate role-specific dashboard views. This means that users from different departments at Asante will have dashboard views with different sets of metrics, showing only the data most relevant to their needs in their roles. The set of metrics that is useful to an ITS team member will likely be different from those relevant to a non-technical corporate executive or a nurse, etc. Third, we did our best to have a modular and expandable backend. Organizing our codebase in such a way allows ourselves and future developers to more efficiently and intuitively add or subtract API calls, dashboard views, or even individual metrics from each view. Finally, it was important to our teams that our app would display infographics and that these infographics would be interactive. Rather than seeing simple numeric values come up on a static page, users will be able to highlight, select, and filter data from each metric and each API call to view and interact with the data exactly as they see fit. That's all for the features. Now I'll pass the presentation to Cole, who will start by covering the project's requirements.
Okay, so when talking about the features, for our workflow, we really broke up the project to a front end and a back end. The front end is what a user sees and interacts with. And as Jacob mentioned earlier, this is a larger project called SecOps that Asante has been working on before. And so when we started off, we were a little bit restricted to being provided a dummy dashboard on the web app. It kind of had to work in the parameters of that, but it gave us a really good starting place and a stick to work towards throughout the whole project. And so the front end itself takes the form of a website you can just go through, or like a web app. You can either visit on your browser or on your mobile device. The web app itself contains individual widgets for the dashboard. Each widget corresponds to a different data source or security tool. And inside those widgets either contains some sort of infographic or data points. This is where the actual individual metrics or pieces of data are stored. And so it's infographic or data point inside of a widget. Additionally, for a requirement for the front end, the client specified that they would like different types of dashboards, for different users and use cases. And so we need to implement that, along with we need to implement the ability to switch between different dashboards too. And so for the back end, which is basically everything the user doesn't see, similar to the front end, what Asante handed us, they already had this outline of an MVC project or design pattern. And so MVC is Model View Controller. It's a very common design patterns when it comes to making web apps. It's really meant to divide up the different aspects and responsibilities of a web app, and especially how data moves between those different responsibilities. The main requirement, and the thing we worked on most throughout both terms and both versions, was just implementing different APIs. APIs are an automatic way to get data from outside sources through code. And for us, most of our APIs were known as RESTful APIs. What this means is, first of all, they're all through HTTP. Additionally, they're all formatted a little bit similarly, although not similar enough to where we couldn't skip reading the documentation. And so for the first version, the first term, a lot of our time early on was not coding the APIs, but instead reading the documentation and just wrapping our minds around how to format them and how they work. And finally, for the backend, the requirement of after we get this data from the APIs, we want to transform it somehow to get the actual useful metrics. Some of these APIs give a lot of data. I think 8 megabytes in text from some of them, and so we really want to use certain algorithms and procedures to get useful metrics such as some sort of average and so on from those APIs. And so for the tools and technologies that we used to build our project, most of it was really specified by the client, which was, luckily for us, meant it really felt like a professional environment for the project overall. You could take a look, and you might note that a lot of this is Microsoft products. That meant that they worked all together, and also there's really nice documentation from Microsoft on everything when we had issues or challenges. And so we worked on the Visual Studio 2022 IDE. Most of our code was published to an Azure repo, unlike some of the other capstones. Luckily, it used Git, so it was basically the same from our end. But when we actually want to go to the website for the repo and look at changes, it was a little bit of a learning curve at first. Additionally, the web app will be deployed on Azure's cloud and using Cosmos DB. We didn't really have to interact with that ourselves, but it's always something we had to keep in mind when making changes to the web app. Additionally, all the code was written in C# for the back end, and the front end was some C#, but a lot of it was like JavaScript or CSS, especially for formatting the front end. And a lot of our frameworks are Microsoft frameworks that go along with those coding languages for web apps. Although an interesting thing is, we began in .NET 5, which is the overall framework that provided basically all the code at first. But the .NET 5 was reaching the end of life, and so the client has switched to .NET 6. Luckily, it wasn't too hard to do, but we decided to refactor before that change. It's for a little bit of a timeline of what we had done throughout both versions of both terms. The first version had about 4 out of 7 APIs fully implemented. Most of our issues was we still had to really read a lot more documentation. Some of the APIs were complex enough where we couldn't get it to work right away. And eventually, once we got them all fixing, we really realized most of the issues were improper password or API key formatting. Some APIs required a full encryption with a nonce, and that was a little bit hard to figure out from just the documentation alone. We began working on making a good-looking front end. We implemented different widgets and infographics that really prepared us for version 2 to fully get all the widgets implemented. And then finally, for the version 1, we worked on getting the back end and front end to communicate. MVC does a really good job of specifying how that should work, but what exactly it looks like with the code was something we still had to figure out. And luckily, we got that done in version 1. And so version 2 is what we have currently. Nearly every API is fully implemented and be called successfully. Splunk is the only exception, mainly because Splunk, to get good API calls, we would have to use the tools ourselves, since the documentation doesn't really show all the possibilities that Splunk has. But there's licensing issues with using a Splunk as students, and it would be I think a couple grand per each of us. And so that wasn't really feasible, and so we didn't really get Splunk implemented. We optimized and made the backend modular. The main use of this is when we had this over to Asante, they were always specifying they would probably add more APIs or change some stuff up. And so making it a modular and pretty easy to use overall means the handover should be simple. We did added the capability of different dashboards and also a simple drop-down to switch between them. And overall, we increased the responsiveness of the web app. At some point, it was taking about 3 minutes to load in, but we fixed a lot of those issues, especially through optimizing the backend to where that's no longer an issue. And so I'm going to bring it over to Jacob, who's going to give a little demo and then close out the presentation.
So here we've got the Asante dashboard. If I refresh the page, you can see each of these cards has to load in from the API. Note this bottom center card is our testing card to make sure that the error function works right. It's a bit silly to say, but gotta test everything, right? We can see actual live data coming from the APIs, and if I pull up the console, we can see each of these says OK. If we hop over to the security dashboard, each of these is junk fake data that I've included in here specifically so that you can show the functioning of the pie charts and how we can reduce them. So when we were testing our app, we mostly opened the app and clicked around and made sure that each of the features worked for the front end. We also opened up developer settings and checked out the source code to make sure that the source code was pulling through because we used a lot of partial functions, right? Um, Most of the front end like data display was done in V1. For V2, it was moving things around and modularizing them. Additionally, for the back end, as we were building additional APIs, we would need the console for V2, and we would just use the ubiquitous printf debugging technique. Very good job on our part, but Asante didn't give us access to a test bed that we could benchmark off of, so we didn't. It was way outside of our scope. For division of labor, I did most of the front end. I did all of the front end. And I also implemented Key Vault. And I spearheaded a lot of the higher level data abstractions. So what were we going to do with modularizing? Cole and Jacob worked on all of the APIs and were fantastic at it. And they did about half of the modularizing. 2/3, 1/3 each. It was equal division for modularization. Um, we did labor allocation and miscellaneous tasks and documentation all very together as a team, very Scrum-like. A lot of the actual labor prioritization was done during weekly meetings where we would stick things on a Kanban board and talk about it. It was super effective. So for the future of the project, there were a few things we didn't get to that we would have loved to get to. One of them is moving the project to Cosmos DB. Our code has stubs for Cosmos DB because it was the next step, but we never actually finished connecting it, and we didn't get enough meetings with Asante to figure out the timelines on those. But basically, what we wanted to do was every week, or sorry, every hour, some of these APIs would run. They would cache an old copy of the data into Cosmos DB, and instead of having to repull the data and transform it every single time, it would pull it once an hour and transform it there so that when the user opens the app, they see the old data from an hour ago instantly instead of having to wait for it to do the extract and transform all on its own. We've had a good time working with Asante on this. It's been a great project, and we trust them to do amazing things with it after we graduate. They intend to launch this and use it daily for a large portion of their staff, and I think that's really nifty. Just to conclude, this is this dashboard's going to be big. It's going to consolidate dozens of security metrics that they have from a lot of their APIs into a single place that they can work effectively. It's going to significantly increase the monitoring effectiveness of their IT security team, and it's going to increase their security response time. It'll be great for them, and I'm really glad that they have this available to them. Thank you.